In this session of the SpaceClaim software training, we will examine one of the practical tools in the design environment of SpaceClaim called fill. In this session, you will become familiar with the application of this command through concrete and hands-on examples. In addition, some important challenges that you may encounter while using this command will be explained, along with their solutions. First, I draw your attention to this pre-drawn 3D geometry. As you can see, this geometry includes rounded corners, fillets, chamfers, holes, and also areas on which shapes have been extruded. One of the most common and primary uses of the fill command is to remove these. Using this tool is as simple as it looks. Select the geometry you want to remove and run the command, and those parts will be eliminated. First, I removed the cylinder that had been created on the model. Now I want to remove this cut portion of my geometry along this side edge. Again, simply by selecting the faces of this region, the software automatically and precisely extends the side faces of the selected geometry so that by extending them, it removes this geometry and replaces it with a new surface. We can also use this command to remove the fillets and chamfers present in the geometry. When you select a chamfer or the fillets of the geometry, the software again automatically extends the side faces to eliminate the selected portion and replace it with a new surface. Now for a different example, this time we select the edges of the geometry you see. And as you can see, the software extends the edges and creates a surface for us. Now again, for the same geometry, by selecting its inner faces, the software extends the surfaces and fills it for us. So as you can see, correct selection is very important for executing this command. Now, in the last remaining part of this geometry, I can either select its fillets and remove them, or select all of its faces and remove it entirely. Now, I draw your attention to another geometry that is a bit more challenging. In the geometry shown to you, I intend to remove that intersection using the fill command. Let's first proceed according to the previous routine. Select its faces and run the fill command to try to remove it and see what happens. As you saw, the software could not execute the command because, as I mentioned, the way this command works is by extending the side faces of the selected geometry to fill that area and replace it with a newly created surface. In this case, the bottom cross-section is problematic for us because the software cannot use it to extend and remove the selected geometry. The solution is to use the split face command, which you learned in previous sessions. So using this command, I will split the bottom face in such a way that a portion of it matches and is equal in size to the cross-section of the geometry for which I want to execute the fill command. After creating the required cross-section, I again select the desired faces to run the fill command, and as you can see, the command executes successfully. Note that with the fill command, you can remove the extra edges you intend to delete. When using this command, it is very important to pay attention to how the software intends to remove the desired area by extending other parts of the geometry. In fact, some visualization is needed in this regard. In the examples you will see next, I want to explain this point more clearly and in greater detail. As you can see in this figure, I select the middle part of this geometry, and the important point is that the two cylindrical sections before and after this geometry are exactly the same size. When I run the fill command after fully selecting this part, the software extends the side faces of this geometry, and since the faces before and after this section are equal in size, this part is removed. And after the command is executed, we see a uniform geometry in its place. However, in the next example, because the geometries before and after it are not the same size, when this command is executed, the software cannot extend the preceding and following faces to create geometries similar to the previous face. Instead, it only does what it can, removing the fillets of this geometry. So instead, I select the geometry by picking the faces one by one up to the point where it's not connected to the next geometry, so it doesn't have to adapt itself to a mismatched section. Instead, it extends only up to where there is a defined uniform size, removes that portion up to that point, and the result turns out like this. For the patch fill mode under Fill, it's straightforward. Go to Fill and switch the mode to Patch. Select the boundary edges around the area you want to fill, one by one, to form a closed loop. Once the loop is closed, you'll get a preview of the patch surface. If it looks good, confirm. Tangent off. The patch only meets the edges G0 positional continuity. It won't necessarily blend smoothly with adjacent faces. You may see a slight crease or angle. Tangent on. The patch becomes tangent blended to all adjacent faces, G1. The transition is smooth and visually seamless, ideal for freeform or aerodynamic surfaces. Select Guide Curve in Fill acts like a rail that tells SpaceClaim exactly how the filled surface should arch and where it should flow. Without guides, the software guesses the shape. With guides, you get predictable, cleaner results, especially on freeform curved areas. For example, here I define the path myself, the curved line I have drawn for it, and the software generates the curvature exactly according to it. I hope this video was useful for you. To benefit from Mr. CFD services, including simulation, consultation, and training, visit our website and contact us via these addresses.